Hello everyone, I'm Indafni from Srinivas Ramanujan Institute of Technology, and I'm studying BTech second year in Computer Science of Engineering, the specialization of AML, and my bearing roll number is 234Z1A3357, and the subject name is Digital Logic and Computer Organization, and the subject code is 23ECE307, and my topic is performance consideration of memory organization. This is the outlines of the topic. Introduction, types of memory, hierarchy memory, cache memory, memory access pattern, data locality principles, memory fragmentation issues, virtual memory and performance, memory bandwidth and latency, advantages, disadvantages, summary and conclusion. This is the introduction to memory organization. Memory organization refers to how data is stored, accessed, and managed in a computer's memory system. Efficient memory organization is crucial for optimizing system performance and resource utilization. Understanding the principles of memory organization helps in designing better software and hardware systems. Memory organization, the structure of memory in a computer, which includes memory cell, memory hierarchy, RAM and ROM, word size, DMA, external memory, magnetic core and memory. And this is the flowchart of the memory. Here we can see the two types of memory in memories, primary and secondary memory. And here in primary memory we can see ROM and RAM. In ROM we can see EROM, EEROM and EPROM. In RAM we can see SRAM and another one. Here the secondary memory we can see hard disk, DVD and flash drive. Types of memory. Memory can be classified into several types including volatile RAM and non-volatile ROM SSD. Each type of memory has its own performance characteristics use cases. The choice of memory types affects the overall speed and efficiency of data access and storage. Memory can broadly classified into two main categories, as I already said about that: primary memory and secondary memory. And here we can see the same flowchart here and some more examples. In ROM we have static and dynamic, and cache memory is also a type of memory. And here we can see the secondary memory like floppy disk, magnetic tapes, CD-ROMs, DVDs, hard disks, solid state drives, and etc. Primary memory. Primary memory directly accessible by the CPU and provides fast temporary storage for data and instructions currently in use. It includes random access memory RAM, a volatile memory used for storing data and instructions that the CPU needs while performing tasks. Once the computer is turned off, the data in RAM is lost. Dynamic RAM, DRAM, needs constant refreshing of retained data commonly used in computers and other devices. Static RAM, SRAM, faster and more reliable than DRAM but more expensive, often uses in cache memory. Read-only memory, only non-volatile memory that holds data permanently even when the computer is turned off. Programmable ROM, can be programmed once after manufacturing. Erasable programmable ROM, can be erased and programmed using ultra-volatile light. Electrically erasable program ROM, can be erased and reprogrammed electrically, often used in both. Cache memory, a small high-speed memory located between the CPU and the RAM, used to store frequently accessed data to improve processing speed. The cache memory located between the CPU and the RAM, and it is used for the take the data which is frequently used, and it is more useful and efficient and work speed than the primary memory. Registers, small fast storage location within the CPU that temporarily and instructions during processing. Secondary memory is non-volatile, providing long-term storage for data and applications. It's slower than the primary memory but much larger in capacity. It The secondary memory is slower, but it's provide the large capacity of storage than the primary memory. It includes hard disk drive. Uses magnetic storage to store data permanently. It's widely used in desktops and laptops for large storage needs. Solid state drive uses flash memory for faster, more durable and energy efficient storage than HDDs, means hard disk drive. Optimal disk, CD, DVD, Blu-ray use laser technology to read and write data. Flash memory, non-volatile memory used in USB flash drives, memory cards, and SSDs. Magnetic tape, used mainly for backup and archival purposes in large amount of offering high capacity and cost effective storage. Hierarchy memory. Memory is organized in hierarchy ranging from register to cache to main memory and secondary storage. This hierarchy balances speed, cost, and capacity, allowing for efficient data retrieval. Understanding the hierarchy helps in making informed decisions about memory allocations and usage. This hierarchy organization organizes different types of memory from the fastest and most expensive to lowest and least expensive. This hierarchy memory set the step by step which are the most expensive to the slowest and least expensive, like in a pyramid type. And here we can see the example of this. First we can see the most expensive on top, where here we can see registers, and the second is cache memory, and third is main memory, and fourth is flash disk, and fifth is a traditional disk, and last is the remote secondary memory. Cache memory and its impacts. Cache memory is a small high-speed storage area that temporarily holds frequently accessed data, and cache memory is present between the CPU and the RAM. The presence of cache significantly reduces the time taken to access data from the main memory. Optimizing cache usage is essential for improving the performance of applications and systems. Cache memory significantly impacts a computer performance by reducing the time needs for data access, which helps speed up processing tasks. And here we can see the where the cache memory is present. Here we can see the first one is uncached system. The CPU and the main memory have the more distance between the CPU and the main memory, and it is a time taken process to search the data what we want. And here the cache system, here we can see the intermediate one is the cache memory, and here the time taken is very less, and here we can take the data very easily. Memory access pattern. Different applications exhibit various memory access patterns such as sequential, random, and stirred accesses. Recognizing these patterns allows developers to optimize data structures and algorithms for better performance. Efficient memory access pattern can lead to significant performance improvements in software execution. Memory access pattern refers to the specific way in which a program or process accesses memory during execution. And this is the example of the memory access pattern. Data locality principles. Data locality refers to the tendency of programs to access data that is close to each other in memory. There are two types of localities: temporal, recent accessed data, and the spatial, data close to recently accessed data. Enhancing data locality can lead to improved cache performance and reduced memory latency. And here we can see some points of these data locality principles. Assets. Data management throughout their life cycle follow best practice for data collection, follow a controlled and consistent data ingest process, keep an original copy of data as they are received, edit all changes, ensure all data are backed up at all subsequent data changes. All data must have metadata. Actively manage, review, and improve data quality. And data management, ethical, transparent, and legally compliant. Use transparent and legally compliant data practices, collect, handle, and store data ethically, publish data and analysis via approved routes, reuse and linkage, adopt common data terms and standards, use data multiple times to maximum maximize values, promote dataset linkage, adopt common data standards across the datasets, apply common terms and definitions. Security. Data access is governed by a set of rules. Ensure access to data is controlled. Protect confidentially. Keep data secure in storage. Use the transmissions. Memory fragmentation issues. Memory fragmentation occurs when free memory is split into small contiguous blocks, reducing allocations efficiency. Fragmentation can lead to increased allocation time and wasted memory resources. Techniques like compaction and memory pooling can help mitigate fragmentation effects. Virtual memory and performance. Virtual memory allows systems to use disk space as an extension of RAM, enabling large applications to run, while virtual memory increases flexibility. Excessive paging can lead to performance degradation. Optimizing virtual memory management is essential for maintaining system responsiveness and efficiency. Memory bandwidth and latency. Memory bandwidth refers to the amount of data that can be transferred to and from memory per unit of time. Latency is the time is taken to access data from memory, which can significantly impact performance. Balancing bandwidth and latency is key to optimizing memory performance in computing system. And this is the RAM latency. Here we can see the data memory to data from memory latency, the delay before RAM can start processing data. Advantages: increased processing speed, efficient use of cache memory, lower power consumption, better multitasking and responsiveness, reduced memory bandwidth requirements, improved scalability for large applications, enhanced performance on multi-core system, cost efficiency, enhanced user experience. Disadvantages: reduced code probability, maintenance challenges, risk of over optimization, reduced flexibility in the program design, increased testing requirements, higher memory usage, incompatibility which higher level abstractions, possible negative impact on power efficiency, difficulty in scaling with rapidly evolving hardware. Summary: performance consideration in memory organization are critical for optimizing compilation efficiency. Memory organization is a key factor in determining a computer performance. The hierarchical theories contains that long-term memory is organized through a hierarchical arrangements of concepts. Main memory is the memory internal workspace in the computer, commonly known as RAM, random access memory. The three main facts of organization memory are data, information, and knowledge. Conclusion: understanding memory organization is vital for enhancing overall system performance. Implementing best practices such as optimizing cache usage, managing data locality, and addressing fragmentation can yield significant benefits. Continuous monitoring and adapting memory strategies are essential for keeping up with evolving technologies and applications demands. Thank you for your attention and thank you for listening my whole video, and thank you so much for giving this opportunity.